All right, class, in this section we're going to take a look at section 12.1, and that's talking about counting methods. Now I'm going to assume in this video that you've actually watched my lessons for 12.2 and 12.3 because it makes it a little bit easier to do problems because I've already talked about concepts like the fundamental counting principle and permutations and combinations. The textbook does not assume that you've seen those, and it shows you longer ways to work things out with tables and trees, and it's much faster if we've watched those other two lectures and gotten the short version of how to do those. So that's the way that I've approached those. If you want to do it the way the book has, you have the textbook option there. You can read through those examples if you like. So how many two-digit numbers can you form using digits 1, 2, 1, 8, 6, 3, 2, and 7 without repetition? For example, 66 is not allowed. So the key here is not what numbers you have. The key is how many numbers you have. 1, 2, 3, 4, 5 different numbers. So 6 different numbers, sorry. 1, 2, 3, 4, 5, 6 different numbers. So the key here is that I can put 6 different numbers in the first location, but in the second location there is only 5 left over, so it's just 6 times 5. So we've learned in the other lessons that if we just multiply 6 times 5, there are 30 different ways to make a two-digit number out of 6 numbers. So a number of ways to roll a pair of dice. Okay, to roll an 8 specifically. So before we get to this one, let's take a look at how many different ways there are to roll dice. So let's say I have a red and a white die. It doesn't matter that they're colored, but the colors are over here. You can see that the black one is actually the white die, and the red ones are the red dice. So here, if you roll 2 ones, you can see that you have 1 and 1, and that's what you would have, snake eyes or whatever you roll. This is actually adding up to 2. Well, if you have a 1 and a 6, you can see the 1 and a 6 there. It adds up to be 7. Over here, you have a 6 and a 6 that adds up to be a 12. So I'm going to see that you're going to see this chart a few times during this lesson. But the commas are just saying we got to add those numbers yet. Like so, here this is actually 4 and 1, which is 5. Okay, it totals to be 5 if you add them together. So the number of ways to roll an 8. Well, you can't roll an 8 on one die. You have to have 2 dice being rolled, and then they add to be 8. And so on this chart, you can actually find those if we take and do. Right here we've got 2 and 6. This is adding to be 8. And everything diagonal here should also add up to be 8. These are all the different ways, the only possible ways to add up to 8. There are 1, 2, 3, 4, 5 different ways to roll an 8. So there are 5 different ways. In fact, there are 36 different ways to roll the dice. If you notice here, this is 6 by 6, so there's 36 total different ways to roll a dice, but here to roll an 8 specifically, there are 5 different ways. Okay. Systematic listing. Your homework is going to ask you to say, systematically list the ways to roll a 5. So going back to our chart here, which you might want to just take a quick picture of or download from the internet like I did, the way to roll a 5 is these guys right here. These are all the different ways. And so basically it's just asking you to list them. 1, 4, 2, 3, 3, 2, and 4, 1. That's supposed to be 1. And then it puts it, I believe, in brackets. But this is what it's looking for in the lab. And it asks for systematic listing of the ways. So these are the answers, and then it just wants you to list them out of different ways to make a 5. So now you've got Susan's friends, Vicky, Louise, Maddie, and Todd have volunteered to help with the preparations for a party. How many ways can Susan assign somebody to buy beverages, someone to arrange for food, and someone to send invitations? Okay, we've got 1, 2, 3, 4 different friends, and we've got 1, 2, 3 jobs. Okay, and no person does 2 jobs. So let's just make sure I had that. Someone to buy beverages, that's 1 job. Someone to arrange for foods, 2 job, and second job, and then someone to send invitations. So there's only 3 jobs, 4 different people. Okay, so of the 4 people, we are only grouping 3 of them. Now, if you've watched the other lessons, you'll know that there is an order because there's specific job titles. So this is a permutation, not a combination. So we're selecting of the 4, a group of 3. So out of the 4 people, you can have 4 people for the first job. They're selecting. 2, 3 different jobs. Second spot, there's only 3 different people. And the third spot, there's only 2 different people left to choose from. So the shortest way to answer this is 4 times 3 times 2. Or if you have your calculator, you can do 4 NPR 3. Or the formula is 4 factorial over 4 minus 3 factorial. So either way you do this, 4 times 3 times 2 gives you 24 different ways to choose these people out of her friends to do a job. Okay. So eyewitness to a crime scene said that there was a license plate of a getaway car, had the numbers TMD, U, and J. Couldn't remember the order. And then the rest of the plate had numbers 8, 6, and 0, but again, we didn't recall the order. So how many license plates must the police investigate to find the car? Now, as far as we're concerned, the math part, we don't actually care what letters they were to find the actual possibilities, but what we do care about is there's 1, 2, 3, 4, 5 different letters used. So 5 letters. And so we have 1, 2, 3, 4, 5 different positions that they were in. So in the first place, there was 5 possible letters that could be there. Second place, you can't reuse the letters. So there's only 4 things that, I wrote 5, but I meant 4 things that you could have in this next position. In the position after that, there's only 3, 2, and then 1 different letters that we could use, because the letters do come first. And then it says the numbers 8, 6, and 0. Well, so that means another 1, 2, 3 places. But in this position, we can only have 3 different numbers. In this position, there's only 2 numbers left. And in this position, there's 1 number left. So I'm circling them because they're numbers and not letters. But here, if we multiply this out, that will tell us how many different license plate numbers the police will be having to search through. So 5 times 4 times 3 times 2 times 1 times 3 times 2 times 1 is 720 different license plates. Okay, and now basically we could also have written 5 factorial times 3 factorial. Would give you that much faster because there's 5 different letters, and notice this is 5 factorial. And again, I'm assuming you've watched one of the next 2 lessons before this one. And then the 3 factorial is there's 3 positions, and we do care about the order. Okay, so that's the shortest way to do that is 5 factorial, 3 factorial. So here we go. Assume we're taking a 10-question. These are supposed to come up in order. Apparently, I messed up my PowerPoint, but here we go. Assume that you're looking at a 10-question true or false quiz. And then the first question it asks us is how many different ways are there to answer all 10 questions? Well, this 2 to the 10th is there is because every question is true or false. So the first question I have 2 options. The second question I have 2 options. The third question I have 2 options. And then I keep doing that all the way to the 10th question. I have 2 options. So if I do the fundamental counting rule, I multiply the 2 times 2 times 2 times 2 10 times, which is 2 to the 10th. So there's 1,024 different combinations of answer choices. Okay, so that's our answer to A. Answer choice B, it says how many ways are there to get no questions wrong? Well, there's only one way to have them all right. No questions wrong, it's having them be all right. There's only one way to get them all right, because if there was 2 ways, that doesn't make any sense. So there's one way to get it right, and then it says how many ways are there to get 1 question right? Well, there's 10 different ways to get, wrong. How many ways to get 1 question wrong? Which means you have to get all of them right except 1. And so the answer is 10, because what you're doing is you're saying I want to have 10 different. There's 10 different problems, and I'm selecting 1 out of those 10 to get them wrong. So there's a combination, because I don't care what order I get it wrong. I just care that there's 1 group that I get wrong. So if you do this guy in your calculator, 10 combination of 1, you'll get your answer of 10. And then the next one says 2 questions wrong. Well, out of the 10 questions, you want to get 2 of them wrong. You want to figure out how many ways are there to get 2 of them wrong. So you just do a combination, because you're grouping 2 questions out of the whole thing. We don't care about what order the 2 questions can come in. So if you do this on your calculator, you get 45 different ways. Okay. Letter C. If you have, if not having studied, you simply guess at each answer, what are the chances of you getting 8 or more correct? Well, 8 or more means that you basically are doing this, where you could get 2 wrong, 1 wrong, or all of them right. And so the fundamental counting principle on the next lesson actually says that you can take the amount of ways that you've done this, which is 1 way, and add it to the 10 ways that we have here, and then add it to the 45 ways, and we get 56 different ways to do this properly out of the 1,024 total possibilities, combinations for the whole test. Sorry, I explained that wrong. I said fundamental counting principle, and that's we're not multiplying, we're adding. We're trying to figure out what are the chances of getting 8 or more correct. This is hard because it's a hard question that you're actually dealing with something from the whole next chapter, which is probability. So it's the amount of ways to do something out of the total amount of ways to actually have this outcome. So we'll have much more explanation in the next few lessons. But there are, 56 different ways to get 8 or more correct, because this is getting 8 correct, this is getting 9 correct, this is getting all of them correct. So there's 56 different ways to get 8 or more correct. And so that's 8 or more, and that's 56 different ways. Out of the total of 1,024 gives you your actual chances. So 56 divided by 1,024 gives me 0.05, basically 5, which is 5%, 5.5% chance of getting basically a B or higher on your test by completely guessing. So not terribly great odds. Here we go, 2 couples. And there's guys, girls, and each couple have bought tickets for adjacent seats to see a musical. In how many ways can the couples be seated if the men are to sit together? And so what we've got here is a permutation of 4 people, and we're grouping 2 of them together, and then we do care about the order that they actually come in. And because we care about order, because we want the 2 men to be sitting together, apparently they're better friends than the ladies, and so we set the ladies on the opposite ends, or not really. So basically we could have 1, 2, 3, 4. So we could have the guys together here, so put GG for guy, or we could have guys here, or we could have guys here. So basically we could work this all out like the book actually does, or it's for permutation 2. So if I do 4 NPR 2, I'll get 12 different ways that we could seat these 2 couples on this particular problem. Okay, and then that's it for this this particular section. If you have any problem-specific questions, because it does ask some interesting questions at the beginning of this section before you're supposed to have watched the other 2, but please hopefully do watch the other 2 before you get too carried away in this section, because it makes things a little bit easier, I believe.